Alright guys, last video. So far we've talked about how to name two different types of ionic compounds. But what about the compounds we find in chemistry that are covalent? Meaning that instead of a metal plus a nonmetal, it's two nonmetals that are joined together and they're sharing their electron density. And so if we refer back to our periodic table, we know that most of our metals are on this side, but when we get over here, here's where most of our nonmetals lie. So we're really going to be talking about bonds between elements located in this part of our periodic table. Okay, so first of all, just like before, we want to check and see what the bonds are between. If they're between a nonmetal and a nonmetal, then we know it's a covalent compound, and these are the rules we're going to use. So I'll just kind of go through the rules briefly, and then we'll do some examples. So just as before, the first element in the compound will be named first, and you'll use its full element name without changing anything. And then the second element, you'll name it as if it were an anion, so kind of just like before, with the IDE ending. But in this case with covalent compounds, this is where the prefixes come in. The mono, di, tri, tetra, penta, hexa, hepta, octa, all those good things. The prefixes are going to be used to denote the number of atoms present, because each prefix, and here it is in your book, each prefix corresponds to a particular number of atoms. Mono corresponds to 1, di to 2, tri to 3, tetra to 4, and so on. Alright, but here's a word of caution, guys, because the prefix mono is never, I repeat, never, used for naming the first element. Alright, so with these things in mind, let's jump to our first example. So, we first look and see if this is a covalent or an ionic compound. So let's look on our periodic table for the elements carbon and oxygen. So here they are. If we know our periodic table well, we'll know that both carbon and oxygen are non-metals. Alright? And in here, this blue on my periodic table is denoting which ones are non-metals. Alright? In addition to the halogens over here. Okay, so we see this is a covalent. So now let's name, according to the first step, the first element just with its name. This is carbon, so we're just going to call it carbon. Alright, now note, since it's the first element and there's only one of them, we don't need to add a prefix. So we don't call this monocarbon. But for the second element, this is where the prefix does come in. So we have oxygen. So just like before, we change that to oxide, but this time we need a prefix to tell us how many oxygens there are. So there's one oxygen, so we use the prefix mono. Alright, and sometimes what you'll notice in writing these is that you may cut off a letter of a prefix just so it sounds a little better in the name. Because carbon monoxide sounds a lot better than carbon monoxide. Kind of sounds interesting. So, there we go. So this becomes carbon monoxide. A carbon and one oxygen. Alright, very nice. Let's move on to our next example, NO2. So again, if we were to look on our periodic table, we see that these are two nonmetals coming together, so we know this is a covalent. So we're going to follow our rules for naming covalent compounds. So again, our first element, there's just one, so we don't need a prefix. We just want to write the element name. Nitrogen. Now, we come to oxygen. And how many oxygens are there? There are 2. So, the prefix that corresponds with 2 atoms is di. Alright, so once we have our prefix, then we name it just like before. So oxygen we turn into oxide. So this is nitrogen dioxide, NO2. Alright, let's move on down. Here we have N2O3. So this is a little different because our first, well, I'll go back through the steps again. This we want to check, is it a covalent compound? And we see yes, both nitrogen and oxygen, we check on our periodic table, are both nonmetals. So we know it's covalent, but this time it's a little different than before because we have two of the first atom. So although we don't use a prefix when there's just one, we do want to use a prefix when there's two. So we choose the prefix that corresponds to two atoms, which is di. Now we name the first atom with its full name, dinitrogen. Alright, and then now we go on. This time instead of two oxygens, there are three. And just like a tricycle, the prefix that corresponds to three is tri. And then we follow that up with oxide. And notice these are connected, there's no dash or anything. So now we have dinitrogen trioxide. Alright, and one more example. So here again we check to see if it's covalent, and yes, we have two nonmetals bonding together. So we're going to take into account, since there's more than one of our first element, we use the corresponding prefix. In this case it's two, so we use di. Then we name the first element just as we would normally, nitrogen. And then we take a look at, oh, alright, we're getting on up there. So this time we have four oxygens. And so because of that, we want to pick the prefix that corresponds with four, which is tetra. But again, kind of like before over here with monoxide, we're going to drop that A because it fits a little better since our oxygen starts with the vowel O. So this will become tetroxide instead of tetraoxide. It's just tetroxide. Dinitrogen tetroxide. Alrighty, so there's some examples on that. And guys, the stuff we've been going over in the video, this can all really be found in the section of your textbook 2.9 called Naming Simple Compounds. And you can find that on pages 35 through 44 of your textbook. And I would really encourage you all to go and check that out. They have some really good examples and they'll walk you through it really well. And in addition to that, there's one section of 2.9 that we didn't cover in the videos, which is naming with polyatomic ions. But we're going to be going over that in SI this next coming week. So that's something you should know as well. We just didn't cover it in the videos. But I hope this has been helpful to you. Please let me know if you have more questions. Come to SI. We can chat more about it and work more practice problems together. Anyways, hope you'll have a great rest of the night.